Okay, so we talked about on Friday that we're starting this new kind of function, which is quadratic. That's what we call it when it has an x squared in it instead of just a plain x. So we're in this new kind of function called quadratic, and this chapter, chapter 5, is going to take us about 5 weeks to work our way through. We're going to break it up into quizzes. We talked about that we're going to take kind of 3 separate sections of lessons and do quizzes on those. So on your bookmarks, remember the first group. Whenever there's a space in the bullet points, that's when we're taking our quizzes. This packet will last you longer than the first quiz. I think it'll last you maybe even the first and the second, or partway through the second, or something like that. So this week we'll have lessons Monday, Tuesday, Wednesday. Then on Thursday we'll review, and on Friday we'll have our first quiz on this stuff. This first part of our chapter, we're going to talk about how do we graph these things. There are 3 different forms that a quadratic equation can take, and for each of those forms, the way we graph them is a different method. Kind of like with linears, how we have slope-intercept method, and we have one way to graph for that, and then we had our standard form, and we had another way that we could graph for that. With quadratics, we're going to have 3 different forms to look at, and they all kind of have their own methods of graphing. Today we're going to talk about what is called standard form. I guess I don't know if you'll consider it good or bad news, but today's is the hardest one. So I guess be encouraged by that when you see this a lot of times we assume that math's going to keep getting harder. This first method is actually the most difficult one, I think, and I think most students agree with me on it, that this one is kind of has the most work involved in the graphing, and then as we go into the next couple lessons, they get a little bit easier than that. So we looked in the lesson on Friday at what effect the a value had, the multiplier in front of the x squared, and what did that do to the graph? It made it wider or narrower. And what about if it was positive or negative? It told us whether our graph is facing up or down. Okay? So in standard form, that a value kind of affects the width of the graph, and it affects on whether it's facing upward or facing downward. We also looked at the c value, something that's added or subtracted to the end of the function, and what did that do?
Made it go side to side.
Not side to side, up or down. It made it go up or down. So move that vertex up and down. Today we're going to bring in this b value, which is going to kind of affect sideways movement, but unfortunately it's not like it's clear cut as you just go sideways b. But in the last lesson, our vertex was always right along that y-axis. Today, it won't necessarily be. Okay, and that vertex is the point where it takes its turn, its highest or lowest point. And all parabolas have a highest or lowest point. So, we got kind of step-by-steps here to help guide us through this process. An important formula for us here is going to be that x is equal to negative b over 2a. And that's the first thing we're going to find. A is the number that's in front of x squared. So in this problem, a is negative 1. B is what's in front of x, so b is 1. And c is the number that's added on the end, so c is 12. So what we're going to do is find negative b divided by 2a. So negative b divided by 2 times a, and I get 1/2. That is the x-coordinate of our vertex. So that's where our vertex is located side to side. So the next thing we want to know is how high is that vertex. So to find that, we're going to plug this x value into our equation. So negative 1/2 squared plus 1/2 plus 12. And you can feel free to use your calculators for these arithmetics. That's fine. I'm not going to take your calculator away from you on the test or quiz. So this ends up being 12 1/4 or 12.25. And that is now 1 point on our function. So the next thing we want to do is find another point. You can plug in any number you want for x as long as it's not the number we already did. So you can't do 1/2, but why you would choose 1/2, I don't know. I always like to choose 0 if I can, But if I got 0 for my first answer, you can't do it again because that doesn't give you any new information. So you have to pick any x other than the one you've already done. I like to do 0, and I always do 0 unless that was already the answer that I got before. When you plug in 0, I get negative 0 squared plus 0 plus 12, which is just 12. That's why I like to plug in 0, because you'll just get the c value. So that's a very easy thing to plug in. When you plug in a 0 for x, you'll just get whatever that c value is. That is a second point on our function. It says find a third point through symmetry, and then connect the dots with a U-shape. So when we go to plot these points, yes, I don't have a grid for mine. So I'll just let's see if I can get a. All right, so the first point that I got was 1/2 and then 12 1/4. You may scale your graphs if you would like to. So I'm definitely going to count my y-axis by 2. Now technically if we count our y-axis by 2, it's maybe best to count our x-axis by 2 as well. But since I have an x value of 1/2, it's going to get a little bit squishy in there. So I'll just let this one keep going by 1. Okay. It's okay to count them differently as long as you say what you're counting them by. It's maybe best to keep them the same, but it doesn't always really make practical sense to do that. So the first point that we found was 1/2, 12 1/4. So I'm going to plot that point, 2, 4, 6, 8, 10, 12, and then just a tiny, tiny bit. And I'm going to plot that point and put a V next to it because that point was the vertex point. The first point you find is your vertex point. So that means that this point is going to be the highest or lowest point on our graph. Then the second point we found was when we chose 0 and plugged it in and got 12. So I'm going to plot that point as 0, 12. Parabolas are always symmetrical around the vertex. What that means is if I take a dotted line and drop it down straight through my vertex, that line acts like a mirror. Whatever is on one side of that line should have something matching it perfectly over on the other side. So I can take that point we just plotted and kind of fold it over that line and make it match over on the other side. Three points are all you need to plot a parabola. More is maybe better sometimes, especially when they're this close together, but 3 is sufficient. And we're going to take those dots, we're going to connect them with a U shape. Try really hard to not make it a V shape. Okay, a lot of students want to make it come to a point. We don't want a point on these. Parabolas should be curved, not pointed. Now this graph ended up facing downward. How could we tell by looking at the original problem that that's what was supposed to happen? Because it had a negative in front of the x squared. The equation was negative x squared, blah, blah, blah. That negative in the very front of it tells us whether our graph is going to be facing up or facing down. So that's one thing you can use to kind of check your answers, that if you look at your equation and you know it's supposed to be facing downward, but your graph is facing upward, something went wrong. Okay, so that's one thing you can use to kind of check your work. All right, let's do another example. So step 1 is that we're going to do x equals negative b over 2a. So in this equation, a is 2, b is negative 8, and c is 6. Make sure you always connect a negative to the number that's following it. So b isn't just 8, b is negative 8. Always take those negatives to be part of the number. So when I do negative b, I'm going to have negative negative 8 over 2 times a is 2. And that gives me a positive 2 as my answer. Then we plug that into our function. Again, you can feel free to use your calculator on these if you want. Let's see, I get 8 minus 16 plus 6, so I get negative 2 on that. And that makes 1 point on our graph. So I could go ahead and plot that point already if I want to. So at 2, negative 2, I have a point, and that point is the vertex. So I'm going to put a V by it. So I remember that that one is the vertex point. And that's where this graph should be symmetrical. So I could put a line through there if I want to kind of remind myself that that's where I'm folding my paper. Or that's my mirror. Then I have to pick some other number for x. Any number I want as long as it's not the number we already used for x. So we already used 2, we can't use 2 again, but otherwise you can use anything you want. So I'm going to plug in a 0. And the nice thing about plugging in a 0 is you just always get that very last c value. Because everything else becomes zeros. So I get a point at 0, 6 that I can plot. If you plug in 0 and your answer is kind of crazy big and you don't want to plot it, pick another number that's maybe closer to your vertex. So if I plugged in that number and it was just ridiculous and I didn't want to plot it, then I would pick something closer to my vertex. So like the vertex is at 2, so I would maybe pick 1 or pick 3. Pick something that's closer and that'll keep your points closer together. Otherwise, you can always just adjust your scaling as well. So now I got 2 points. The nice thing about parabolas is they should always be perfectly symmetrical. So I can take that point that I just plotted and I can fold it or reflect it over that mirror and get a point over on the other side that's exactly the same as it. And then I can connect those points together with a rounded U shape. Make sure it's not coming down straight to a V, but that it's rounding out to a U. Questions? All right, so in this one, A is a half, B is 1, C is 12. First step is that x is equal to negative b over 2a. So I'm going to do negative 1 over 2 times 1/2. 2 times a half is just 1, so this gives me negative 1. Then step 2, we plug that in to find out what y is. So 1/2 times negative 1 squared plus negative 1 plus 12. Makes 11.5. And again, you can feel free to use your calculator and the arithmetic, that's okay. Make sure you're careful with parentheses though, so that when I'm plugging in a negative 1 that I put parentheses around that negative 1, otherwise you might end up with some problems there. So make sure that you're putting parentheses around what you're plugging in. So that gives me 1 point on my graph. Now when I go to plot that out, I'm probably going to want to scale this thing by 2's on the y-axis. I could also scale by 2's on the x-axis if I want, or I could just scale by 1's. That's kind of up to you. Just make sure you say what it is that you're counting by. So if x is negative 1, I'm counting by 2's, 11.5, be right about there. I'm going to put a V by that point to remind myself that that's my vertex point, or I can just go ahead and draw my line through it to remind myself that that's my mirror point. Then for step 3, I can pick any x I want as long as it's not the x we already did. So I can't pick negative 1, but I'll pick 0. Plugging in 0, you will just always get your c value. So I get 0, 12, and I can plot that point out. And then using my mirror, I can take that point and fold it over, and I get a matching point on the other side. Connect those dots to make a U shape. Remember, we can check our equation and get some information about it. We said that our A value affects up or down. It's positive, so we know we should be facing up. It also affects width. 1/2 is a small number, so that means this graph should be facing kind of wide. It's not going to be really tall and narrow. It's going to have kind of a wide vertex to it. And then that C value of 12 tells us that our graph should be hitting the y-axis up at a value of 12, which is where it's hitting. That just doesn't happen to be the vertex, but it still does hit the axis at that point. Okay? Questions? To graph inequalities, we're going to graph the line exactly the same, and then we're just going to need to do some shading. So to graph exactly the same, the first thing we do is x equals negative b over 2a. A is 2, b is negative 5, c is negative 3.
What gave you x equals negative b over 2a?
That will always be our first step for how we find our x-coordinate of a vertex. It's just a formula. So when I plug that in, you get negative 5 over 2 times 2, which is 1.25. Then step 2 is plug that in.
What is A?
A is the coefficient of x squared. It's the first letter or the first number in the equation. And then b is what's in front of x, and c is the constant that's by itself. You can use your calculator when you plug that in, and I get negative 6.125. I wouldn't round them off too much. It's okay to round them off a little bit towards the end if you need to, but don't round this all the way just to negative 6, because that might cause you some problems when you go to plug in some other numbers. I don't have a graph grid on this screen, so I'm just going to go ahead and sketch one out so that we can plot as we go. So my x is going to be 1.25, and then 1, 2, 3, 4, 5, 6, and a little bit. So my vertex is going to be about down here. And that vertex is where we get a mirror line that we can fold across.
How do you know it's right and the y equals line?
We're plugging our x answer into the equation. To find what y is when we have that particular x. Then we pick any x we want, as long as it's different than what we already did, but why you would ever pick 1.25, I don't know. So we're going to pick 0. If I plug in 0, I get negative 3. The nice thing about plugging in zeros, you will just always get that c value because everything else becomes zeros. So 0, negative 3 is a point. And then I can fold this over. This point is how far away from the dotted line? 1.25, right? Because that was our x value was 1 1/4. So I'm going to go 1 1/4 away. What's 1 1/4 plus 1 1/4? 2.5. So we're going to go 2.5 there. 125 plus 125 is 250. So we get our points there. And now we're going to connect them. Now when we connect them, we have to be careful that this is an inequality, not an equation, which means we need to think about dotted or solid. This one happens to be solid because it does have the equal to bar, but we need to think about whether we have a dotted or solid connection. Then we're going to pick a point to test and see if it's true. I like to pick 0, 0. You can always pick 0, 0 unless that is a point that's actually on the equation. In this case, it is not. So I'm going to pick this point of 0, 0 and plug it in and see if I get something true or false. So I plug in 0, 0, and that gives me 0 is less than 0 minus 0 minus 3.
Is true?
That is not true. 0 is not less than negative 3, so this is a false point. Which means that I don't want to shade 0, 0, which means I'm going to shade outside of this whole thing, and it just kind of starts to look like a line then. Okay. If 0, 0 worked, then I would shade inside. So instead of shading like left or right or above or below like we did when we had straight lines, we're going to be shading outside or inside.
How does the step 1 and 2 relate to the graph?
Step 1 and 2 plot the vertex point. So x is 1.25 and y is negative 6.125 is the first point that we plotted on our graph.
Okay, and then how'd you get the 0 and negative 3?
Pick any number you want for x. So I picked 0 just because it's easy to plug in and plug that in. And that gave me negative 3. And that gives me my second point that's on the graph. That's 0, negative 3.
Okay.
The third point comes from folding that over to the other side. Alright, so for this one, x, we start by doing negative b over 2a. That's always our first step here. A is 1, b is negative 2, c is negative 3. Make sure you're always taking those negatives as being part of your a, b, or c. Don't just lose your negatives. So I've got negative 2 over 2 times 1, which gives me 1. And then I plug that in.
What do you plug the 1 into?
In for x.
Wouldn't it be negative 1?
It's negative, negative 2. So the formula is negative b, and b is already a negative 2.
Oh, yeah.
So that gives me negative 4. So that means my vertex is at 1, negative 4. Then we get to pick any x value we want. So I'm going to pick 0 and plug it in. And that gives me negative 3. Nice thing about plugging in zeros, it just always gives you that c value. So 0, negative 3 is my second point, which I can fold over to get my third point. And because this is an inequality, we have to think about dotted solid shading. This is going to be a dotted line because there is no equal to bar. It just says y is greater than. It doesn't say greater than or equal to.
Just write the dot.
So yes, if you forget and you've already done it in pen, you can just write dotted next to it.
Always forget that.
It's better to remember late than never, so then you can just write dotted next to it if you forget. Then I need to pick a test point. I'm going to pick 0, 0. And I plug that into the inequality. And I get 0 is greater than 0 minus 0 minus 3. Which is true. 0 is greater than negative 3. So that means I want to shade 0, 0, which is on the inside. So I'm going to shade the whole inside. We have one more, which is a system. The only difference here is that we're going to plot 2 of them on the same thing. So it's like just doing 2 problems in one. So the first one I'm going to do is this one, and I'm going to go through our steps with that one. In this one, A is 1. What is B? 0, because there is no x term. So this is like plus 0x, and C is negative 4. So it's not that A is just the first number and B is the second number and C is the third number. You have to make sure that they're lining up with the right letters. A goes with x squared, B goes with x. So if there are no x's, then B is just 0. So our first step is negative B over 2A, which gives negative 0 over 2 times 1, which is 0. Then I plug that in and get negative 4. So 0, negative 4 is my vertex, and that means that that's where I get to fold my paper. Now when I pick an x value, I can't pick 0 because if I do, I'm not getting any new information because we already used 0. So that means in this case, I have to pick something else. I always pick 0 when I can, but every now and then you can't. So I'm going to pick 1 because that's still pretty easy to plug in. So I get 1 squared minus 4, which is negative 3. I'm going to fold that over to get my third point. Then I decide dotted or solid for this. This one needs a solid because it has the equal to bar. And then I'm going to test the point 0, 0. When I plug that in, I get 0 is greater than 0 minus 4, which is true. So I shade 0, 0, which is on the inside. Then we graph the other one. So for that one, A is negative 1, B is negative 1, C is 2. So negative B over 2A is going to be negative, negative 1 over 2 times negative 1, which gives negative 1/2. Then I plug that in. If you're using your calculator to plug it in, make sure that you're using parentheses. Otherwise, you will get a wrong answer. Okay? It is important that you put parentheses around that negative 1/2, and don't try to take care of any of those double negatives by yourself, because one of them we actually can do and the other one we can't do because of the squared. So if you're using your calculator, just type it in exactly as it is with parentheses around the negative 1/2. That gives us, let's see, 2 1/4. And so that's my vertex point. Negative 1/2, 2 1/4. So V by it to remember that that's my vertex. And I could put my dotted line through it for my symmetry line. Pick any x I want. I'm going to pick 0. Plug it in and I get 2. Fold that over the line to get a matching point. This one has to be dotted. It will not always be that one of them's dotted, one of them's solid. They could both be solid, they could both be dotted, 1 and 1. Okay, so make sure you check them individually for each. Just happens to be on this one that we're getting one of each. Then I want to pick a test point. I'm going to test 0, 0, so I plug that in. If I plug in 0, 0, I get 0 is less than 0 minus 0 plus 2. So 0 is less than 2, which is true. And I'm going to shade the inside. So like when we did straight lines, our answer is where we have both of our shadings. So that is in this football-ish shaped region. Okay. Questions?
Should we do different colors?
You can, you don't have to. For me, it helps me kind of see what's what. But you don't have to use different colors. If you just shade them both lightly, then the darker shading will be the answer. Your homework tonight comes from 5.1 and 5.7. Make sure you notice question 51 after those parentheses. A lot of students don't see that back there, and then you'll just get that wrong. So make sure you notice that problem 51 is back there. It says here you don't have to label the vertex or the axis of symmetry. The directions will tell you to label them. They're going to be in your graph, so you don't, they'll probably be drawn in, but you don't specifically have to say anything about them. Okay, but notice that you do have some from 5.1 and then you have some from 5.7. 5.1 are just the equations. 5.7 are the inequalities, so that's where you will need to graph the shading also. Okay, 5.1 is just the lines. 5.7 is the inequalities, so that's where you will have shading also.